discuss the theory of, you already know the theory. Only few points I would like to highlight. First 10 questions are based on this diagram. In this diagram, you can see it's an electrochemical cell. The pressure on the left piston is already in the diagram. It is shown as, somewhere it must be written. Yeah, 2 bar. So a constant pressure of 2 bar is maintained on the left piston, and a constant pressure of 0.2 bar is maintained in the right piston. And you can see the gas, H2 gas is filled here. In the solution, we have HCl 1 molar. And based on this, we'll ask a lot of questions. Many questions we can ask. So what kind of cell is this? Is this cell is having liquid junction potential? Question number 1. Oral question. Let us start with some oral questions. Anyone? Is this thing has liquid junction potential? Anyone would like to answer? No. Please respond. Any one of you? What do you think? This cell has a liquid junction potential or not? Yeah. You want to say something? Yes, good. Go ahead. Somebody wants to answer. Come on. You all know this. What is the liquid junction potential? I know this. Okay. So you don't want me to discuss liquid junction potential, na? Tell me in this cell, even if you are mistaken, nobody is going to laugh at you.
Liquid junction potential is always present.
Always present. Okay. So you're saying that in this cell, liquid junction potential is present. Where is that?
At the porous plug.
No, but unfortunately, this cell is having no liquid junction potential, because liquid junction potential is only the potential develops when 2 liquid junctions are there. Junction and liquid, you already know. If 2 liquid junctions are there, separated by a porous wall or separated by something, then only liquid junction potential exists. So in this cell, there is no liquid junction potential. Okay. Why? Because you can see there is no salt bridge. If there is no salt bridge, you can see the reaction is common. So there will not be any liquid junction potential. If you see a standard galvanic cell, you will find a liquid junction potential. Okay. So I would like to see a close discussion on this one. The fundamentals of electrochemistry. So we have discussed a lot of ionic equilibrium. Let us talk something about fundamentals of electrochemistry. So first question is, the answer is, there is not going to be any liquid junction potential in this cell. Second question is, what kind of cell is this? That's a very pretty simple answer. Tell me. This is a concentration cell. This is a concentration cell. What is a concentration cell? A concentration cell is a cell in which the concentration is different in 2 compartments of a galvanic cell. But we could not see any difference in concentration here. How can we say this is a concentration cell? So we said that this is, here the pressure of H2 gas is different in 2 compartments. And that pressure difference is creating kind of a voltage in this galvanic cell. So it is a kind of a concentration cell, and we used to call it electrode concentration cell. Second question is also oral. Now, third question is, which is going to be the last part of this question. Let us start with this one. If this cell is, if the pressure on left hand side, that means the pressure which is at 2 bar, if I increase the pressure by a differential amount like a dP, what will happen? Anyone? Of course, piston will go down. Of course, piston will go down. If I increase the pressure by dP, what will happen? The piston will go down. So see this diagram very carefully. What will happen when piston will go down? Okay. You can download the diagram. I have already shared the problem, and try to answer the following question. The following 10 questions are based on simple this one. That is going to make the electrochemistry concept, all the concept we are going to cover here very quickly. If you have any doubts, about reversibility of a cell, what is electrochemical cell, what is the potentiometric arrangement, how electrodes, anodes, cathodes, etc. If there is any theoretical doubt, we can cover, we can easily cover in this particular problem. So the question is, in the given electrochemical cell, the pressure on the left piston is increased by dP so that the H2 gas is allowed to pass through the porous plug. As you can see the porous plug over here, so that this H2 gas will start coming out of this porous plug. Of course, there was a 2 bar pressure, and probably we want that this gas is bubbled here at 2 bar. So you can say that we are bubbling this gas here at 2 bar pressure. That is it. And here, whatever gas will be liberated will be quickly coming into 0.2 bar pressure. So that is the situation. Assume ideal gas behavior of H2 gas under the experimental condition, given this and this, and 1 farad is this. If the volume on the piston A decreased by 1 meter cube in joule, 1 meter cube, what is Q reversible of the system in joules? That's the first question. There is a correction. What is Q reversible in joules of the system? Sorry for this. This is the first question. Take your time, solve it, tell me. There will be 10 questions based on this. If the volume of the piston A is decreased by 1 meter cube in the joules, what is the Q reversible of the system? What is the value of delta U of the system when the volume of H2 gas decreased by 1 meter cube in the left compartment in joules? You also have to calculate delta U in joules. Thirdly, calculate delta H of the above described process. In the same process, calculate delta H. Fourth, calculate delta G of the above described process in joules. Fifth, find delta system, delta surrounding, and delta total in the above mentioned processes in joules. 6. What is the value of EMF developed across 2 platinum electrodes in volts? 6. What is the total electrical work done in the process in joules? Electrical work done. 8. What is the total PV work done on the system in joules? 9. What is the efficiency of the galvanic cell? And 10th, what do you think? The overall process is reversible or irreversible? So this one single question is going to follow up the whole electrochemistry galvanic cell funda. See this diagram and answer this. That means calculate everything about this. When this cell is operationalized, what will be the voltage difference? What kind of current you can draw from there? What will be PV work? What will be non-PV work? What will be delta H? What will be delta U? What will be entropy change of system? What will be entropy change of surrounding? And what will be the entropy change in total process? And what do you think? The process is reversible or irreversible? That will complete the discussion. So please guide me. If any one of you can guide me, that's fantastic. Just start doing this thing, or I feel that this is the answer. Okay. Any one of you? So these are the some set of questions. Okay. And if you wish to take some time on this one, you can always take time. Anyone? See, this is very interesting problem. So if we want to solve it in interesting fashion, that's great. Because, you know, JEE advanced examination always asks some very interesting questions. So always some questions hide some kind of funda. And that is a very unique presentation of the problem. It took a lot of time to prepare this question, think about it, what JEEs asked so far in electrochemical cell, what they will ask, how interesting this question is. So this has a lot of, you know, things. So what do you think? We should solve it, or you will try your time?
We'll try.
You'll try. If I share the answer immediately, it will start by you getting biased. So I'll share answer after say 8 to 10 hours. It will okay.
Yes, sir.
Okay, done. Try this question. Not very good question, but not very, calculative question, only conceptual question. This is regarding electrochemistry, first 10 questions, and it will also relate intimately to entropy, and it will relate and, cover the whole thermodynamic concepts. Very interesting question if this one is. Okay. Few other questions are like this. In ionic equilibrium, as you know, I love ionic equilibrium because that is something where a lot of creativity is there. Find the solubility of a salt A plus B negative. Already shared this question with you. Find the solubility of salt A plus B negative in water. This is a special question because you have to find the solubility in water. You don't have to find the solubility in some, at a given pH or something like this. Because those questions are easy, straightforward question. But when you do this kind of problem, they require some kind of intuitive thinking, taking adjustments. And so this is one such questions. And I believe that the four problems which I have discussed here, Jay can never go outside these four questions. Okay, that's my guarantee to you. If they ask very ultra difficult question, they could not go. And there's some reason why I'm saying this. So these four questions which I have taken here, 11, 12, 13, 14, and 15. So there is a mistake. One question is by mistake has come here. Just strike it off. Sorry, not this one. But this is part of the bigger question. What do you think the overall process is reversible or irreversible? Sorry for this, because we have to create these questions so that you can. So find the solubility of A plus B negative. In this question, you see what is happening. Only one thing is hydrolyzing. The idea is you will notice that KSP and K is varying. And with the variation of KSP and Ka, the problem solving technique changes and your assumptions will change. Because in all situations, you have to avoid a cubic equation type of situation. So in these questions, the whole idea is what is your intuition, how developed your intuition is, that what kind of approximation you are going to take is going to fit in this scenario. So this is the whole idea. So only workable problems are given, should be created. So these are some workable problems where you will get a very well-defined answers. That is it. Well-defined answers means you can take an approximation and that will be valid. You can always check the approximation. Similarly, this question is there where both cation and anion is hydrolyzing. So this is also a very simple question, but can be asked. Time and again, I have done this mistake. Many times it has been repeated, but now finally, this is 10 to the power minus 5. I've already shared it. I've asked my operator to remove this, but 2-3 times I've asked, but still it is there. And one last question in which I have taken KSP of a simple salt. You see there is a diacidic, dibasic acid. So it is going to hydrolyze in 2 steps. It is going to hydrolyze in 2 steps. So that is also, and all the questions here are not requiring, if your approximations are perfect, it's not going to require a lot of calculation. Hardly 3, 4, 5 line solutions are there. So try these questions and that will make your solubility equilibrium and fantastic. And if you have any doubt in complexation equilibrium, you can ask me right now. So having done this, you want to do it and then I can discuss it later on. In the last class, I have discussed few questions. If you have any doubt, you can ask me. Truncated octahedron. So that time I could not explain very well. So I have given you my trademark figure, which I have created. So I hope that after that, you can understand truncated octahedron and how the truncated octahedron is related to all other things. So I hope that you understand that thing also. I believe truncated octahedron and related things I shared some file with you. So if you have any doubts, you can ask me specifically. Any theoretical doubt I can discuss. Otherwise, our agenda will be shortened. Anyone? Anything you want me to discuss? Any theory concept? Any theoretical concept? Atomic structure, gaseous state. Few questions. I think that in GTA today paper, few questions I have not discussed because of shortage of time. We can also discuss those questions. One question was there in physical chemistry. This question number 32, question number 31. What kind of problems were they? How to solve them? You already have done it. Question number 32. Are you sure that ml is equals to 0? Anyone? How come you're so sure that ml is equals to 0?
Single electron species.
For single electron species, ml is equals to 0? No, beta, ऐसा नहीं है. Wave function of an atomic orbital of a single electron atom or ion is given. Doesn't really matter. See, this wave function is valid for not only single electron atom, it is valid for everyone. Although it has been given for a single electron, it has been given, but this is valid for everyone. No? This wave functions are always valid for every species. Only thing is, you know, this Z you see, Z will become Z effective in those scenarios, but it will retain its concept. This form, it will be retained. Okay. Or these constants will somewhat change. So it is valid for all the atoms. So have you seen the wave functions? Have you seen the wave functions? You say the p orbitals are p orbitals को देखना है तो p orbital में आप देखो कभी cos theta होता है, कभी sin theta sin phi, and sometimes it is sin theta sin phi, and sometimes cos theta sin phi, something like this. Cos theta sin phi, no, I think sin theta sin phi, p orbital, 3 types of orbitals are there. Do you remember?
Yes, sir.
Okay, so how can you say that? Can you really say that? Let's discuss this. Can we say that ml is equals to, the idea is ml for p orbital can have 3 values, -1, 0, and +1. So you have very conveniently said that this is pz orbital, and some one of them is px orbital, and some one of them is py orbital. What is the basis of this px and py? What is the basis of this px and py? So your answer will be like this. So if it is a px orbital, if this is x-axis, the probability will be maximum along x-axis. You will probably say this. So if the probability is maximum along x-axis, that also means that the probability is vanished along this plane. And what is this plane? YZ plane. So on YZ plane, there should not be any probability density. Then only we will agree that this is a px orbital. By this logic, we determine the px orbital, and we determine the value of ml by looking at the orbital. What is there, sin theta, cos theta, etc. Okay. And we also know this one convention is there. If there is z orbital, this is x orbital, this is y orbital, then there is a convention that this angle theta will be measured from this point, and angle phi will be measured from x-axis, and the phi will be measured in along xy plane. That is another thing. So on the basis of this, you kind of determine the orbitals. For example, if this is the situation, if you remember, and if this is r, then of course this distance is equals to what? R sin theta. And so this distance is r sin theta cos phi, and this is r sin theta sin phi. So whenever you see r sin theta sin phi, you say this is py orbital. Whenever you see r sin theta cos phi, you simply say this is px orbital. And whenever you see r cos theta, you simply say this is pz orbital. My question is, can you really relate this to ml number 0, -1, and +1? How come? Can you do it? So in this question, it was asked. So what was your basis of taking this ml? Anyone? You've taken it, you remembered it, or how you have determined? I just don't want to interfere in your knowledge, but what knowledge you have, you must tell me, na? So that I understand how you have concluded that if I can see the sin theta term here, if I can see cos theta term here, then ml must be equal to 0. Any idea? Anyone? Any tukka? Take a guess, a wild guess. What is the problem? J,
Theta is unique.
yeah,
Cos theta is uniquer than sin theta and sin phi. I mean, cos sin theta and cos phi and sin phi. And 0 is also unique than -1 and 1.
ML is also unique. That is why.
Guess.
Yes. Okay.
And
Yes, yes, yes. So I'll show you the real story, then you will determine on your own. Okay. So this, there are three parts to the, you would decide yourself and don't get confused. Okay. Since the question was there, that's why I'm asking. I'm telling you the answer. RR is the radial part. Theta is the theta part. Phi is the phi part. Solution to all three parts you have to do on independent basis. That means solution Schrodinger equation solved in such a manner that we get solution of this, and we get solution of this, we get solution of this, and these solutions are combined together to form the clear solution. The solution of this one is very easy. Most easy is the solution of this one, and which says that phi is equals to e to the power minus I m phi. Okay, plus minus this. That is the solution to the this part. What you can call theta will be called azimuthal part. Theta, because the quantum number L is related to this theta, and phi we should call what? Sometimes theta is called zenith part, because like in our Earth system, this is North Pole. So you're measuring angle from this. So sometimes it is called zenith part, and this phi part is called azimuthal part. It's amazing. So this is the phi function. Now, if the possible value of MR, quantum numbers, you already know, this is plus minus L and 0. You already know. Plus minus L and L minus 1 up to 0. So there must be one value 0. And that 0 will be when it is 0, then phi is equals to what? The phi function is equals to what? This is simply, if you put here m is equals to 0, that phi is equal to vanished, because that will become what? 1. So in this function, can you see any phi? No. When you could not see any phi, that means here m is equals to 0. In this way, precisely we can relate this cos theta to m is equals to 0. You understand? Everyone? Any doubt? Because this is wave function, everyone is mugging up, but there is something there in the solution, which is a mathematical fact. So if ml is equals to 0, that means phi part will not be there. Okay. Now coming on to this part, that nobody is going to ask you what is px and py. Tell me what is the value of +1. Px is -1 or +1. Nobody is going to ask you, because this question is wrong question. If I ask this in MCQ, that will become very difficult, because this level is beyond your syllabus. But I tell you as an information, and the answer I have given is related to this. Reason I would like to discuss, if m is equals to 1 plus 1, then this phi function will be e to the power minus I phi. Sorry, plus I phi. So that is equal to what? Cos phi plus I sin phi. Have you ever seen a wave function in which there is a imaginary number? No. So in fact, the wave functions are imaginary numbers. In fact, the wave functions are imaginary numbers. Amazing. And when Schrodinger comes up with this idea, it was a hateable idea that time. People say that what you're doing, complex number you're using to getting the answer. But you will be amazed to know that quantum mechanics has made it possible to see that without complex number, you could not explain this quantum world. So they have to deal with this complex number. But luckily they get rid of this complex number. And how you come to know such convenient, real number p orbitals, and also because of this fact that the Schrodinger equation is del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square is equals to 8 pi square m upon h square E minus V times of psi. That is a second order differential equation. And in second order differential equation, if solution to equation is A and solution to this equation is B, then amazing thing is that A plus XB is also solution to this equation. That is why Schrodinger has chosen this equation, or people has chosen this form. Otherwise, they would have written this equation in many forms. Like you can create a differential equation in many forms. That is why this equation was chosen in such a specific manner. That the one solution, A solution, B solution, then combination of A and B is also solution. If A, B, C is solution, then combination of A, B, and C is all this is solution. And that is why when you carry out the molecular orbitals, you mix all so many orbitals because they resemble those kind of situation. Okay. So this is about the quantum mechanics. Why I'm telling you this story? Why I'm telling you this story? I'm telling you this story because of this fact. Then what happens? If you see if an orbital is, one part is cos theta plus I sine, phi. Function is like this. Other function is like this. If you take m is equals to +1. And if you take m is equals to -1, then it will be what? Cos phi minus I sine phi. So what you can do, that was solution A, that was solution B. Make a linear combination of these solutions, A plus B, and that will become 2 cos phi. 2 cos phi, and then this 2 cos phi term will appear in the Schrodinger equation. So you might be noticing it if you see very carefully. So in this way, it could be related. And similarly, another combination is there. If I show you some wave functions, especially you can see here 0, 1, and -1 for py, it has been written. Okay. So cos phi is coming from simple linear combination of +1 and -1, and sin phi is coming. That means these two are doubtful. We could not really say 1 and -1. We could not really say. There is a confusion. Okay. There is a confusion because this is the linear combination of these orbitals which has been created. But now by convention, we say one of them is +1 and one of them is -1. So this is by convention. If you don't know these stories, nobody is going to ask you. Crux is this, that there is no doubt about this, because for here, m is equals to 0. But for +1 and -1, it is very difficult to predict that which function is which. That is my idea. Okay, I hope that you understand. So this is one thing I saw in this paper. We don't have to think much about it, but one thing is this. About question number 31, these type of questions started getting asked in ITJ after once J has asked this question. And the crux of this question number 31 was, which today's class I haven't discussed, that the molar conductivity, the crux of this problem is that specific conductivity is additive. That means if you say K of NaCl, you can hypothetically write K of Na plus K of Cl negative. That is the idea of this problem. And then K of Na plus, specific conductivity of Na plus can be related to lambda of Na plus into what? C, concentration of only Na plus divided by 1000. So that is the beautiful idea on which this question is based. So simply get the individual concentration of ions and then use this funda to get the answer. So this has been asked in JEE maybe 5-10 years back, but no new question has been framed. We are creating questions on this idea, only this idea. And all other ideas are, finished, because how to get the conductivity from, what is that? Solubility product from conductance measurement. And sometimes they have also asked conductometric titration, strong acid versus strong base. Here I have another question. What kind of graph you expect if you have a weak acid like a CS3CH, and along with that phenol, another weak acid phenol is there, and you are titrating it with NaOH. what kind of graph you can expect here? Conductometric titration. Tell me, these two mixture of weak acids are there. That's another question which I would like to ask. Anyone?
Increasing, so then steep increase. First normal slow increase, then steep increase.
First normal increase, then steep increase.
Yes, sir.
This is how?
Yes, sir.
But beta, these are two mixtures.
Then if it's a mixture, then
Okay, fine. Why? Just tell me why. Let me tell you then. Theory of this. This is also related to ionic. So you have CH3COH, you have phenol, and you have Na plus, you have OH negative, and you have nothing like H plus. It is weak acid. Okay. Suppose I have 10 of this, suppose I have 10 of this, and I have added one NaOH into this one. That's initial. One NaOH into this one. What will happen? Of course, this OH negative will combine with what? You tell me. Which is stronger acid? CH3COH. So the next situation will be 9, 10, and this is of course 1, and this is 0. Do you agree that still the number of ions is equals to 20? Initially, you try to increase the ions. Sorry, not ions. I'm so sorry. The number of ions is equals to what? Na plus is 1, and CH3 एक और कॉलम बनाना पड़ेगा मुझे. CH3CO negative और एक कॉलम और बना लेते हैं. PHO negative phenoxide ion. Okay, so in that situation, this is 1. So number of ions here I will write. Number of ions totally at this situation is Na plus 1, that's 2. When you are adding 2 moles of NaOH, then it will become 2, that will become 0, that will become 10, that will become 8, that will become 2. So number of ions becomes 4. This situation will continue till what time? When CH3COH is completely vanished, it will become 0. At this point, when this will become 0, this will be 10. And this is also 10. And this is also 10. And this is 0. At this point, total number of ions become 20. Steadily number of ions is growing. Afterwards, if you add another NaOH, then it will become 11. This is now 10. This is 0. This is going to be 9, and this is going to be 1. And this is simply 0, and this is 22. What do you think now? What kind of graph it should be? So I tell you, the graph will first increase, then it can go like this, it can go like this. Both way it can go.
lower ones.
Now it is your intuition. It will go lower or upper. It will depend on what conductivity of phenoxide ion. So what do you think conductivity of phenoxide ion is more? Because what is the reason of increasing? Because ions are adding. But what kind of ions are getting added now? Phenoxide ion. Now phenoxide ion, naturally, it's a big ion. Okay. And as compared to what CH3CO negative ion, our intuition is telling that phenoxide ion should have a lower speed, although that's a very tricky situation. Why? Because in CH3CO negative, there are 2 O negatives. So viscous forces may act more on CH3CO negative. But when it comes to phenoxide ion, that is something water absolutely hates it. So there is no water of solvation. Okay. One negative charge is there, it is getting delocalized, it is not going to be liked by water very much. So at this point of time, chemistry become very critical. Here, either you have to remember or you have to rely on how, the examiner is how open-minded. So I don't think examiner is going to, ask you something, but our data tells us that since it is very big, moves like this, and then it will go like this. But full marks to anyone, I could not predict, because these are, multivariate problems. How can I say that phenoxide ion is going to be moving faster than acetate ion? Acetate ion has 2 O. Okay, the oxygen is the charge is getting delocalized on 2 oxygen atoms, but then 1 oxygen atom is there. Hydrogen is quite obviously going to like that oxygen atom. But phenoxide ion, water almost hates it. So that is why, because phenol is not dissolved in water. You have to dissolve it. You have to add NaOH to dissolve it. That is the greatest proof. So when you study chemistry, you have to get a lot of feel. You have to understand the characters. So that is why a very famous question in organic chemistry says, how you can dissolve phenol in water? The answer is add NaOH. But if you add sodium bicarbonate, it is not going to dissolve. That's a very famous question in organic chemistry. And that's kind of a distinction. If phenol is there, some other acidic group is there, how you distinguish it. In fact, phenol and benzoic acid, if you want to distinguish, that's the best test. Try to add some NaHCO3. Phenol will not dissolve, but benzoic acid will dissolve. But try to add some NaOH, of course, phenol will dissolve. That's a confirmatory test as far as the solubility is concerned. So this is the answer. Convinced? So this is, yeah.
There will be also dissociation of PHOH and acetic acid. Those will also cause the difference.
Dissociation of PHOH? No. That is very, very slight, because these are okay. You are telling me that when CH3CH was getting titrated, it is getting converted into COH negative. Okay. Tell me, what is the buffer range? What is the buffer range? pKa will be ranging of 5 to 8. Let's take 5 to 8. What is the acid strength of phenol? 10. At this point, phenol is not even 1% dissociated. Check it out. That is why I have taken this choice.
And acetic acid is dissociating more than phenol, so graph will be little different for both. When
both are weak acids, and practically speaking, both are almost equal to 0. They dissociate. How is this dissociate? Out of 100, they dissociate like 1 or 2. Getting what I'm saying?
Even H plus conductivity is 100 times such.
Even there, but H plus is not free now here. H plus is not free. That's a buffer solution. Yes. If H plus free, if free H plus is there, immediately PHO negative will grab it. It will not let it remain free. Okay, agreed. H plus ion can be very large, but they are not present in much concentration. Here the solution is ruled by PHO negative, PHOH, okay, CH3COH and CH3CO negative. H plus OH negative बेचारे बहुत कम है. They are so small, so never think about it, though they are moving fast. Done?
Yes.
So
anything else? Once can you explain why the graph steadily increase after the slight increase?
After this, finally, what will happen? Everything is finished. Okay. Now you are simply adding NaOH. When you are simply adding NaOH, then not only ions are increasing, but there's a OH negative ion, which is very fast moving ion. It has exceptional stability. That is why that's a very rapid increase. Understood?
Yes, sir.
Yeah. And one more thing. What about on this axis? What is there? Molar conductance or conductance? What is on this graph? Small things are there. Always believe, fundamentals are very small.
Conductance.
Yes, absolutely right. That's conductance. How you decided all of a sudden? Whose conductance is increasing? Molar conductance we could not talk about. No? So basically conductance is increasing. Okay. Another question. These small things are very important. Have your basics absolutely clear. What is conductance? If I have a beaker, and this is 1 liter beaker, I put 2 electrodes into this one. And I want to measure the resistance between these 2 points. Of course, that is going to give me the conductance. Okay. So we measure the conductance C of 1 liter or only the conductance between these 2 electrodes. What we measure? When we calculate conductance, we calculate conductance of 1 liter, or we calculate conductance between the electrode.
1 liter.
Think about it, Ved. And
I think those between the electrodes, no, sir, because the effect will be caused only between those 2.
Yes, beta, yes. Because it is not different from electricity. Ved, increase your confidence level, okay? If you see this, if you're measuring conductance of, resistance of a wire, you're of course measuring this as the wire. So you should consider this a wire. Okay? This is a wire. So you're basically measuring conductance of this wire. The only difference between this and this is, here the carriers are electrons. But here the carriers are electrolytes. Got it? To make this point absolutely clear. Small thing.
How,
Yeah, tell me what
how do we know other parts are not involved in this?
this is how. See, we have three quantities. We have three quantities. One is C, one is K, and one is lambda m. We have three quantities. So,
Yes.
between these two electrodes, whatever solution is there, and whatever number of ions are there, okay? So, conductance depends on two things, proportional to number of ions. Sometimes I start making mistakes. So, conductance of number of ions, and secondly, speed or mobility of ion. Do you understand? Okay. Now, this is conductance. When you talk about the K, it is simply the conductance measured by a hypothetical electrode, which is having an area of 1 centimeter square, and distance between them is equals to 1 centimeter. Exactly. So see the correspondence. The formula is, see from the formula, C into cell constant is equals to K. Done? Now do one thing. Dilute the solution. Dilute the solution by a factor of 10. That means the concentration become what? 1 by 10. If the concentration will become 1 by 10 and the speed of the mobility of cations and anions will also increase by the same factor, increase or decrease by same factor, what will happen? This will change by the same factor. This will change by the same factor. Do you agree? Both will change by the same factor. You dilute it. Do you agree or not?
Yes, sir.
Why? Because conductance is also depending on number of ions. That number of ions becomes what? 1/10. And speed or mobility of ions has increased marginally. Suppose for every ion, speed has increased and becomes 1.2. So what happens? First, the number of atoms were n. Okay. And in 1 cc, how much were there? Suppose small n. So now they become capital N by 10. And the speed factor was first x. Now it is 1.2x. Here, this is small n become n by 10. And the speed factor, same, x, 1.2x. So see, the fractional change in both is same. So that is why when you dilute a solution, both conductance and conductivity both decreases by same factor. And that is why they look like same. C is equals to K into C into cell constant is equals to K. Do you understand, everyone? That is the idea. So first major thing, keep it in mind. The conductance is between the cell, electrolyte cell, what you're measuring, the electrodes. And that is why you define cell constant. You always say that where to measure conductance, you have to measure the conductance between two defined cells. To make this funda clear, then this chapter, then this portion will also become very clear. This is area, and this is L length, and this is very well defined. You always measure conductance like this. Ask some conceptual questions on this one. If we are a little bit interactive, otherwise I'm not discussing these things. Otherwise, maybe some students have some doubts, and I don't want to cater to this. Now, when the IT examination is 10 days back, till you register yourself, sir, I want to discuss this whole, okay, in the most important fashion. So, C is the conductance, K is the conductance, and lambda m is the conductance. Can you, anyone tell me what is the correct definition of lambda m? Correct definition. Anyone, please cooperate. Please initiate the dialogue. Molar conductance. You'll say it's the conductivity of 1 mole. I also know this. How it is measured. You know, when you measure conductance or resistance, you have to specify how you are measuring it. What kind of electrodes you are taking, where you are putting the solution. Anyone? How to measure the conductance? Because you have studied networking, you have studied electricity, current electricity. So you obviously have seen in current and electricity, it's very important to describe how you are going to measure the resistance. So similarly, lambda m is what? Molar conductance. That is kind of reciprocal of resistance. How you are going to measure it? What kind of electrodes you take? Anyone? Please, I'm not judging your knowledge. I know you are all performing very well, all the toppers. But some concepts, if I can add, make it simple. That is why these classes are there. If you have any doubts, please ask me and I'll describe it. And for that, you have to respond. How you measure lambda m? Any one of you?
Conductance of the hypothetical cell where the area is of unit and the volume in it is 1 liter.
Just a minute. Who is telling this? This is a problem that I could not see. Anyway, you tell me. Tell me. Very good. Very good. You're telling me. Please guide me.
We have a hypothetical cell of units area. Electrode is of unit area.
Hypothetical cell of unit area.
In which we have 1 mole of the electrolyte present.
Are they parallel? Avinash, they're not parallel, na? Okay, I tell you then. What is molar conductance? See. Now just make this in your mind absolutely clear. These are two electrodes. We have dipped in a solution. So the whatever portion of solution is falling between these two electrodes, keep it in mind, and whatever ions are there, they are contributing. The ions which are outside is not contributing. Of course, they're not contributing. Okay. And this particular thing is called conductivity cell. In this conductivity cell, there is an area and there is a length between the electrodes. We call this cell constant L by A. We derive it by physics formula, which is the very common thing that resistance is directly proportional to what? Resistance is directly proportional to length and resistance is inversely proportional to area and multiplied by a constant. And which we call in physics what? Rho. Rho L by A. This is resistance. So we do what? Reciprocal of this. So 1 by rho, and this is, you already know why I'm doing this at this hour, I don't know, but still, this is C, since a very basic question was involved, and 1 upon rho will be called now K and A by L. So simply we put C into L by A is equals to K. This formula is absolutely getting away from the physics. Nothing new about this. Only form has been changed. That's conductance. Okay. This is the macroscopic picture of conductance. I have created a macroscopic picture of conductance. Now in physics and chemistry as well, there is always a macroscopic story and a microscopic story. If you are also interested in microscopic story, so C is equals to K divided by cell constant, you can say. And I can also say C is equals to, for some function of number density. This is number of ions per unit volume, I would say. Or more specifically, I can say if the ions are different, I would say N positive into what? Z positive plus N negative into Z negative. That will correspond to the total number of ions. Then some constant should be there. This constant will include viscosity and a lot of other factors, and also the speed of ions. And there must one more factor should be there. Not only the numbers, there should be one more factor. Let's call this lambda plus and let's call this lambda minus, which will represent the speed, because of course speed is also reality. So this is a microscopic picture. And that is a macroscopic picture. Okay, that is conductance. So you have to answer these questions. What happens when we add water into this container? When we add water into this container, the solution will become dilute. When the solution will become dilute, then conductance will change how? C dash. K is a constant which is not going to vary. but this n plus is going to be n dash plus, z plus is not going to vary, and this lambda plus is going to be varied, plus dash I should write, plus n negative dash, z negative not going to vary, and lambda negative dash. Do you agree that here n plus dash is less than n plus, but lambda plus dash is greater than lambda plus? That's a unique factor. So in this way, two contradictory things are there, but what will dominate? Definitely n will dominate, because the fractional change in lambda is going to be small, but fractional change in this n is very, very large. So that is why n always rules. N always rules. That means if the numbers are decreasing, no way conductance can increase. Is that clear? So this microscopic picture is making you immensely satisfied. Okay, I'm very sure if you're diluting it, then C dash will definitely be less than C. So this statistical picture has made it clear. Anyone has any doubt? Is that thing absolutely understandable? आगे बढ़ो मैं अभी conductance बता रहा हूँ. I am just discussing conductance. If you wish, I will also go for the specific conductance and then molar conductance. Okay?
Yes,
चलो
sir.
yeah. So this is conductance. Two pictures I have shown you, macroscopic and microscopic. Now I will take this macroscopic picture and I will come back after some time. What is this K now? K, specific conductance. It is a hypothetical quantity. It's a hypothetical quantity and a very, very lovely quantity. This is best quantity is K, hypothetical quantity. Here, the distance between them is 1 centimeter. An area is 1 centimeter square. And whatever solution is there in between this, the conductance of this will be called K. Okay, precisely in 1 centimeter square, this is called K. Tell me, please respond. Tell me, can you build this kind of electrode? Such tiny electrodes, 1 centimeter, 1 centimeter. Can you really build, and can you really maintain distance between them 1 centimeter practically? Chemistry is a practical science based on common sense. Answer is no. Such a delicate instrument you could not create. It's a hell lot of a difficult thing to just devise that kind of electrode. Now the question is then how you calculate it? How you calculate this K? So answer is, for this, few set of scientists or very established laboratories have already conducted experiments in very standard sets, and they have taken a solution of KCl at different concentrations, 0.1 m, 0.0111 m, 0.12 m, something like this. And in all these concentrations, they have taken a cell in which they filled KCl, and then a cell which was clearly very well defined. That means its L by A was very clearly defined. So in this way, they have conducted experiments and they have calculated in every data, they have calculated C1. Then they have a very well-defined value of L by A. And from that, they have calculated K1, K2, K3. And believe me, in lab, this data is always provided, standard set of data, through which we can determine this specific conductance. Otherwise, it's a hypothetical quantity. It's a hypothetical quantity. Calculating, unit electrode, to find a unit electrode, distance between them it's a very, very difficult task. So somehow scientists determine this in a separate set of experiment, and this data is always provided. Once this data is provided, you will prepare a KCl solution in lab, and you will try to see it is matching with which one of them. Why it is so? Because it is very difficult to prepare a precise solution. So what you will do, you will make it a random solution. Okay, but you know how much KCl you have to weigh, because weighing is also a very sensitive experiment. If you have decided that I am going to weigh 0.002 milligram, it will be from morning to evening. Sometimes he will measure 0.0021, sometimes he will measure 0023. So what he will do? It's very difficult. So whatever you are getting, you will do this. You will put in water into this one and you will prepare a solution. Then you will match whatever data it is matching. So in this way, whatever KCL solution you have prepared, you know from the data what is the value of K of this. Okay. And this K is used, and now you take your conductivity cell. You take your own conductivity cell and you dip this particular KCL solution into this one. Whatever you have prepared, you already know the value of K here, and you will calculate, measure by Wheatstone bridge arrangement. You will measure the resistance. From this, you will get the conductance, and then you have the formula C into cell constant. So in this manner, the cell constant, which you already know, in the first experiment, you already know the value of K, you already know the value of C, you determine the cell constant. The first set of experiment is to find the cell constant with the help of KCL. Once you know the cell constant of a cell, then you take an arbitrary solution. You will put the same conductivity cell into this one, and now you have poured an NaCl solution. Suppose it is 0.1 m. So you already know the cell constant, which is L by A, and you will measure what? C multiplied by C, and you will get K of NaCl. So a simple story I told you. Can you really get the value of K so easily? No. You will only get with some standard values, you can get the value of K NaCl. Okay. Do you really know the conductivity cell constant by just measuring the length and measuring the area? Impossible. It will consume a lot of time. It is rather impossible. Okay. So somehow you measure by different shaped conductivity cell. Okay. You measure the conductance and you know the cell constant of those with the help of the described experiment, and you get the value of KCl. But once you have determined NaCl, nobody will deny it that this is conductance of. However, you measure how you measure it doesn't really matter. It is conductance of exactly 1 centimeter cube solution measured between 1 centimeter distance, and area should be 1 centimeter square. That's for sure. That is for sure. So this little conceptual part your mind should be very aware of. Why I'm telling you this story now? Now I'm coming to the final part of the story. So for the molar conductance, what you need? Take two large, infinite, surface area electrodes and fill the solution with this one. And suppose this is 1 centimeter square. And suppose the distance between them is 1 centimeter. So no, the ions which are falling in between will give a conductance of K. So this cell will also give conductance of what? K. And this will also give conductance of what? K. Okay, now you know that all these resistances are joined in what? Parallel. 1 by R plus 1 by R plus 1 by R is equals to C plus C plus C. So you can say N times of 1 by R summation is equals to N times of C. So you can say that in this manner, all the conductance will increase. So we simply say, what is molar conductance? Molar conductance is equals to K times volume that contain volume in cc that contain exactly 1 mole. That is lambda. K into volume in cc which contains exactly 1 mole. Now try to understand if you have any doubt here. Suppose I have 0.1 m NaCl. So for molar conductance, I need 10 liters of this because 10 liters containing 1 mole. I will fill this 10 liter. This 10 liter will take a space of what? 10,000 centimeter square. And they are separated by 1 centimeter. How many cells will be there? How many cells will be there? 10,000. So there are 10,000 cells which are connected how? In a parallel manner. So we can say lambda m is equals to K into 10,000. K of NaCl in this situation to 10,000. And hence we have the formula lambda m is equals to K into V. This simple formula has this idea. I hope that you understand. What is the definition now? Molar conductance is a hypothetical quantity as if it has been measured in what manner? Like taking two infinitely large electrodes separated by a unit distance, and you have filled a solution which contains exactly 1 mole of electrolyte. And when you measure the conductance, that is called molar conductance. That is the macroscopic picture. And microscopic picture, then what will be what? Molar conductance will be Na plus into Z plus into lambda plus Na minus into Z minus into lambda minus. Here these NAs are constant. Kitna bhi dilute karo, how much you dilute, but this Na is not going to change. So why molar conductance increases by statistical picture? Can you explain? Because this is Z plus and Z minus increases. That is why lambda m increases. Okay, that's the simple funda of what? Conductance. And I want that clarity in the mind before we tackle this. So summary is this: C, K, and lambda. Volume. How much volume is involved? Falling between electrodes. How much volume is involved? 1 cc or 1 meter cube. Choice is yours, but we like this choice. It is conductance of 1 cc. Same solution. It is conductance of 1 cc, but C is the conductance of falling between the electrodes and lambda m. That volume in cc, which contain exactly 1 mole electrolyte. See, this is the summary of conductance. Three quantities. Any doubts, please ask me. Otherwise, I should discuss some other things. नहीं ठीक है, फॉर्मूले से पढ़ लिया था. Anyone? Ved Prakash, not studied or forgot?
Forgot.
Forgot. Okay. Because you're so thorough. So now your concept is clear.
Yes, sir.
It's looking difficult, amazingly. Conductance part, always students want, sir, please revise it. Always they ask for the revision. In so many years of my teaching, I find, because we have to capture it at one go, and that is why we have made a summary of this. Okay, now you really want to test yourself. Start doing what? This is, suppose I am talking up for a particular solution, 0.1 m NaCl. So if we have 0.1 molar NaCl, I want to find the conductance of this. On what factors this conductance will depend? First, will it depend on concentration? First, concentration, yes or no?
Yes.
Yes? Okay, not NaCl. Suppose we have NaCl solution. The conductance, first quantity conductance, will it depends on concentration? Yes or no? Yes. Will it depend on, let's call it A, B? Will it depend on cell? Kind of cell in which you are measuring?
Yes, sir.
Yes. Will it depend on the beaker size?
No,
No.
sir.
No. And will it depend on the amount of NaCl?
Yes.
No. Depend on concentration. Concentration and amount. I have to distinguish now. You understand? Or this is confusing?
Yes, understood, sir.
Understood? Yeah.
So it depends what we mean by amount of NaCl. Are we changing volume or not?
How should I put it? It is volume of NaCl I should write. No? Let's change it. Volume of NaCl. Solution. Is it all right now? No. It will not depend.
Electrolyte or in the beaker?
In the beaker, that's what I'm telling you. If the beaker is very large, doesn't really matter. Important thing is what kind of cell you are taking. If your cell is this tiny sized, you're only going to get conductance in between this now.
But number of ions will decrease because of increase in NaCl volume.
Okay, then I have to write
Concentration will increase.
volume of NaCl solution, keeping concentration constant.
Yes.
Now, what is your answer?
No.
Now it is no. All right. So first thing is students always think that, sir, if I will take one bucket full of water and I will measure conductance, then more conductance I will get. No, conductance is measured by conductivity cell. Only those electrodes, the solution which is falling in between them. First concept is this is clear. Okay. Now K. Will it depend on concentration?
Yes, sir.
Yes, sir.
Yes. Will it depend on type of conductivity cell?
No, sir.
No. It is independent of whatever cell you take. So this is one beautiful quantity we get. Doesn't really matter what kind of cell you are taking. It is independent. So this is a better quantity because this is characteristic of NaCl. Otherwise, you're changing the cell and C is changing. That is why C has not a lot of izzat. Lot of izzat. K has lot of izzat. But then why K has lot of izzat, but still we need lambda m? Because there's a problem. K depends on concentration. In physics, the R was independent of concentration. In physics, this rho was if it is for aluminum, that is constant. It is for copper, it is constant. Until unless you are going to take an alloy, it is constant. But here it is varying on the concentration. That is why we have to devise a new quantity which is called molar conductance. That is why we have to devise a new quantity which is called molar conductance. Now coming on to the molar conductance. Will it depends on concentration?
No, sir.
Yes.
Yes,
Yes.
sir.
Okay. Second. Will it depend on cell constant? No.
No.
It is not going to depend on cell constant. What cell you are going to use measure can have a characteristic value at a given concentration or for a given electrolyte for characteristic value for a given electrolyte. That's most important question.
No, sir.
Yes, Peter, that is why it is most important. It has a characteristic value for a given electrolyte. When you start decreasing this concentration, then you might have read this na lambda m by root c. That touches it and you get what? Lambda m naught. What is this? It is characteristic. At zero concentration means what? Practically very low concentration. You have a well-defined value of lambda m. And that thing is not possible for K and C. Can you imagine that for NaCl, there is some characteristic value of K? No. There could not be any characteristic value of K, because if keep on decreasing the concentration, take the statistical picture, keep on decreasing the concentration and K will decrease. Eventually, it will become 0. So at a very dilute situation, K will tend towards 0. But lambda M is not going to tend to 0. It is going to have a characteristic value. Now, at this point, if you have any confusion, I'll tell you statistical picture. That is why we have created it. What was lambda M? There was Na plus into Z plus into lambda M plus Na minus into Z minus into lambda M minus. And what about K? That was N, italics N, but not Na, plus into Z plus into lambda M plus N minus into Z minus into lambda M minus. See this. This N plus and N minus can tend towards what? 0. But this Na is not going to change, because you're measuring molar conductance now. You'll always take Na amounts of cations and anions. So only thing is this is going to vary. And this steadily increases. So lambda M not tends to 0. It started increasing. And at very dilute concentration, it attains a characteristic value. So that is the difference. Can have a characteristic value for a given electrolyte. That's the beauty of this whole topic. What? You know, by measuring conductance, you're commenting on sodium. You're commenting on that sodium is moving slower than potassium. Cannot you think about it? By measuring this, hypothetical resistance and all this quantity, applying your brain and analyzing this, we say that, what statement we say? We say that lambda M of KCl naught is more than lambda M naught of NaCl. Now, we also from Kohlrausch law, we know lambda M naught of this, lambda M naught of K plus lambda M naught of Cl minus is greater than lambda M naught of Na plus lambda M naught of Cl minus. Cancel it out. So by measuring this doing this measuring resistance, seeing the variation of concentration with molar conductance with concentration, you are finding out that's the beauty of chemical thought. From macroscopic picture to microscopic accountability. So you have this account that K plus moves faster than Na plus. You have never gone and asked, hello K plus, tell me how fast you move. You could not do it. It's rather impossible. But this is the thought process through which we get to this point. So that is the beauty of this topic, okay? Any more doubts here? So if you revise it like this, we can create a lot of MCQ questions and all this. You can see this for this conceptual kind of a thing. And Jay always believe in asking conceptual question. Practice. 70 to 80% time you will get practice questions, but 20% will be unique questions. Anybody can set. You see, every week, if you ask me, I will give you 7, 8, 10 original questions, which will be different, very, very different. You would have never solved it. Okay. So that is how Jay can also do this. Okay, there is a question, sir. What about the other conductivity cell that involves a cylindrical tube? Very good. And 2 platinized electrode. That is why I'm telling you, take whatever shape, doesn't really matter, because from that shape, you will get K. Somebody has measured K, and now you take whatever shape, you are free to take any shape. So actually, conductivity cells are pencil cell types like this. Very nice designs are there. Okay. Something like this, it's like a cylindrical thing. And there are 2 electrodes and solution is measured. Of course, they're not parallel. But then what is going to happen? From this, you will measure C and you will multiply it by cell constant L by A, and that will take care of everything. You will get K, but this K will be conductance of exactly 1 cc. It will be exactly 1 cc. Believe me. Done. Anything else you want to ask, which you have a doubt? In today's class, somebody asked me, yes, enthalpy. What is enthalpy? Should I discuss? Give function, enthalpy, anything? Visualization? Any doubts here? No doubts.
Sir, when we discuss the graph of CH3COOH or phenol with NaOH, no, sir,
Yeah. I've discussed.
there we assumed some things for phenols because of its bulky size or thing. Can you say it once again?
See, if we are in a solution and we have a phenol and NaOH, and we are titrating it with HCl, sorry, phenol and CH3COH. It is reacting with OH negative. First, OH negative will react with this. And suppose I have CH3COOH plus OH negative. This reaction I would like to write. Suppose I have 0.1 of this and I have added 0.02 of this. 0.02 is a very large quantity, you know. I will assume that 100% reaction has taken place. This will become 0.08. This will become 0. This will become 0.02. Of course, it is not 0. In this situation, there will be some OH negative which is coming from some place. Of course, from where it will come, you know. If the solution is acidic, still if it is acidic, it is coming from water. Don't worry, it is not going to be 0. We will assume this and we will find the pH. Let us find the pH. Suppose the equilibrium constant of CH3COH is equals to, simplified, 10 to the power minus 5. So, right now H plus concentration is equals to what? H plus concentration is equals to K into CH3COH concentration, which is 0.08 divided by 0.02. So, which is 4 into 10 to the power minus 5. You have added 0.02 mole of OH negative. They are quickly consumed. And this many H plus ion is there. And this means that OH negative is how much? 1 by 4 into 10 to the power minus 9. Which is, you can verify, it is 2.5 into 10 to the power minus 10. Where they have gone? 0.02. What is left? Only this. Now, in this situation, how much phenol is dissociated? Let us also calculate this. The K of this is 10 to the power minus 10. So at this pH, 10 to the power minus 10 is the K of this divided by, let us write the equilibrium H plus ion concentration, which is 4 into 10 to the power minus 5 is equals to pHO negative upon pHOH concentration. So this is coming out to be 1 by 4, that means 0.25 into 10 to the power minus 5. In other words, see this. This is basically how much? 0.25 upon 10 to the power 5, which is 25 upon 10 to the power 7 is equals to pHO negative. pHOH. Beta, what is the meaning of this? If pHOH is 10 to the power 7 is equals to how much? 1 crore. If pHOH is 1 crore, then pHO negative is how much? 25. What do you think? Is it dissociated? No. So it is just sitting like this. It's waiting for its time. Till the time the whole CH3COH is not converted into CH3CO negative, dare not it is going to react. Am I clear?
Yes, sir.
Yeah. So that is why I told you the ionic equilibrium, electrochemistry, the thermodynamics chapter you see in the physical chemistry. From thermodynamics, liquid solution is there, electrochemistry is there. Only 2 chapters are there. thoroughly study, well, only 3 chapters are there. Thoroughly study thermodynamics, thoroughly study and revise ionic equilibrium conceptually and chemical kinetics. Atomic structure is a very nice topic, but mostly people have mugged it up and they have done it, and ITJ could not go beyond certain limits. That is why it's a very safe chapter. Mole concept, your common sense is there. You can always tackle. Okay. Surface chemistry, small thing is there. Apply thermodynamics to get the concepts, everything clear. So all the chapters are related to thermodynamics. So go through the thermodynamic concept, go through the ionic concept. That is very important. The whole theme of a JEE physical chemistry good paper will be like this. Last year, they have asked a very standard examination paper. And this time, maybe if they are going to ask very simple question, then be prepared for that too. Do a lot of practice. Sometimes they ask a very silly paper. Such simple paper that is not really differentiating between those who have worked really hard and those who have not worked so hard. So in Narayana system, routine practice is too much. I am aware of this fact that you have done a lot of practices and a lot of practice question papers are there. You have already done. Only now go for the quality work. Spend 1 or 2 hours time, 1 hour time for a quality thing, but never compromise on the speed and accuracy. That you take care of your own. If you have any doubt, anything where on these areas we can work out, then in the last time we have some advantage into this one. If you have any confusions regarding this, yeah, mobility. Somebody, Avinash, you're asking for mobility. See, mobility is what? I think this concept is clear, and conductance, this is clear. Mobility is what? See, speed has no meaning in solutions, because if electric field has more strength, then of course speed will go on increasing. So we have to fix the electric field to find the speed. So that is why speed is defined as speed. Suppose V positive is the speed divided by electric field strength. And we very well know that electric field strength can also be in uniform electric field. We can write it V by D. What is V? Voltage between these two terminals. And what is D? Distance between these two parallel plates. So we say that speed divided by potential gradient. This is called ionic mobility. So hardly in your books you will get reference of this. So ionic mobility will be this U positive and U negative. These two terms are reserved for ionic mobility of cations and anions. Guess what? It will depend on what? Of course, ionic mobility is related to what? Speed. Speed is related to the molar conductance, which you get it from some other sources. So a derivation is a very beautiful derivation, but if you don't want to do derivation, you can do the dimensional analysis. So U plus is equals to lambda plus upon Z plus into F. You can do the dimensional analysis to get this relationship. Okay. My advice is to always go for the dimensional analysis. Otherwise, you want to take the challenge, then devise a, this thing, but then it will become a physics problem to find the mobility. Define a container of volume V, put a solution of concentration C here, divide the distance is equals to say L, and then speed is suppose some speed you must be measuring, and suppose you take speed, this is anionic part, this is cationic part. So the cation is suppose moving with certain speed towards this side. This cation must have some speed V plus. So the usual thing is take this distance is equals to V plus. Whatever cations are there, they will definitely reach here in unit time. So when volume is given, concentration is given. So you have the numbers of cations, which is going to strike in 1 second. That will give you I plus current due to cation. So when you get the I plus, Then I just describe the I plus. So V is equals to IR. Voltage is equals to IR. So that means V by R, that means V into C is equals to I. So from this I, you can get what? C plus, conductance due to cation into the voltage. Now we know that from conductance, we have to reach where? Specific conductance. So C plus is related to K plus into this voltage. And subsequently, we will change this K plus into lambda plus. We have the formula into V. By this route, you can get this very simple definition. Don't try to do this. Just do the dimension analysis. You will get the same. What is the dimension of this U plus? If the speed is in centimeters or meters per second divided by voltage gradient, that means volt per meter. So that is coming out to be meter square volt second. Try to see that, is it also the same? What is the unit of F? Unit of F is coulombs per mole. Yeah, coulombs per mole. Coulombs per mole. Lambda, what is the unit? Do you remember? Ohm inverse, centimeter square, mole inverse. So this mole inverse will cancel. Now ohm inverse, of course, that is going to convert into what? Conductance. And sorry, ohm inverse is going to be ohm and ohm. From ohm, you can do this thing. Okay, I think you can do better than this. Please verify. Are you getting the same dimensions both sides? Otherwise, this is the way you can do it, by using very simple definition of conductance. Now in ITJ syllabus, this ionic mobility has rarely been asked, but if they ask it, that will be a very unique thing. Just remember this formula. U plus is equals to lambda plus Z plus into F. Take care of the dimensions. That's very important. Anything else? So try the questions. Yeah. Please try to... Exactly. What?
Sir, in the microscopic derivation of conductance,
Yeah.
what is the Z plus and Z minus, sir?
Z plus and Z minus is the charge on the ions.
Okay, sir.
They are very important, because if they are more, that means that their speed is going to be more. You know why? Because when you accelerate them in the electric field, if the density is more, they are definitely going to have much bigger ionic mobilities. And that is why you notice that the ionic mobilities of sulfate ion or phosphate ions are very large. So sometimes they can even ask you, ionic mobility, greater the charge on an ion, that is also a very important factor for the ionic mobility. But here it is in denominator, na?
No, sir, in the derivations.
Yeah, in the derivation. So you're clear what I'm saying?
Yes, sir.
So develop this microscopic and macroscopic picture, that will help. But that is it. So once ITJ has asked that question, and now that question is become a benchmark, a very nice question, where first time they thought that K is additive. Students really don't think about it. That's a very good question. Now we have to see what kind of question they are going to ask in conductance. Maybe ionic mobility sometimes, because that is a very important quantity in higher physical chemistry. Very, very important. So I've discussed something about this, but don't research. Make your mind click. You have very good practice and you're doing well. So no overthinking, but few concepts should be clear. Anything else if you want to know about over voltage, etc. If you have any doubts, you can always ask me in the next class. Please clear with your doubts. Okay. If any theoretical doubt is there, please share with me. Then this time can be utilized. And I will also enjoy the sessions. Okay. So try these questions. That's a very nice question. I have given you electrochemistry. In next week, I will also create few more questions. And I'm very happy that many a times questions which I have predicted as it is come into the J examination, especially in ionic equilibrium and solid state many times. Maybe this time this electrochemistry problem is also a very important problem, because this is containing a message. If you try well, you'll find that. So maybe in these questions, if we can 2 or 3 very good questions that can create a difference, then I will be very happy. Diamond and graphite questions you have already done. I think phase rule and all this.
Can you repeat, sir?
Diamond and graphite conversion processes. Somebody asked me today's standard state. Now I'll quickly discuss also that thing. Standard state, because sometimes you have a lot of confusion in standard state. I forgot. Yeah. See, there is a huge amount of confusion even in the definition of enthalpy. Please behold, if a reaction is there, N2 plus 3H2 changing into twice NH3. If I ask you, what is enthalpy of this reaction? Then somebody will say that, sir, N2 gas was there, H2 gas was there. After some time, only NH3 gas is there. In this process, some heat was liberated. That heat we snatched out. And so the change is delta H of the reaction. So in the initial state, and we have gone to the final state. So it looks like this, that in the final state, there is no N2 and H2 left. They are vanished. And in the initial state, there was no NH3. So there is a problem now. If we write delta H, theoretically speaking, we write it like this. We write it like this, twice into molar enthalpy of NH3 minus molar enthalpy of N2 minus thrice molar enthalpy of H2. Theoretically speaking, we should write like this. Now this H of NH3 must be equal to U of NH3 plus P into V of NH3 or V into P of NH3. Similarly, this NH2 should be equal to U of N2 plus P into V of N2. And similarly, this should be equal to U of H2 plus P into V of H2. So you will say that, sir, these quantities are absolute values could not be determined. Maybe absolute values could not be determined, but they have a fixed value. That's the second law. That's the first law. So they should be there. So that means we have to define, first of all, what is U? U is easily defined because temperature is given. No problem. But we also have to define P. We also have to define P here. We also have to define V here. Then only we can define H. And then only we can define delta RH. See, this is the problem. So how can you find delta H without defining a precise value of pressure to this? We all know H is equals to U plus PV. So if P is varying, what do you think? H will be constant, kya? No, that will not be constant because P is varying. So if P is varying and gas is not an ideal gas, something is liquid or something is solid, what do you think? H will not change? Definitely it will change. So without specifying pressure, how can you define delta RH? So the question is, pressure of what? Product or initial pressure or final pressure or what? That is the biggest question. That is the biggest confusion. And that is why I described this. So answer is that this is, answer is, see the definition carefully. Always it should be written NH2 plus 3H2 changing into NH3. If you want to find the enthalpy of this, the pressure of this should be known. Pressure of this should also be known. Pressure of this should also be known. Well-defined pressure. Temperature should also be known. Then only enthalpy could have any meaningful value. Then only enthalpy could have any meaningful value. And for all the world scientists had decided that this pressure will be taken as 1 bar. This is also 1 bar. This is also 1 bar. And temperature of your choice. But normally the most of the data is presented on 298 Kelvin. But in US and UK, when handbooks you will take, they will provide formula so that you can calculate delta R H naught at any temperature. But it's not, is totally related to the pressure. That izzat is given only because of pressure. This is a hell lot of is a important quantity. Here it is. So this vital part we miss, and we always think like when a reaction is taking place, N2 is vanished, S2 is vanished, NS3 is formed, and whatever enthalpy is there, it is true only to the some extent, but it's not entirely true. Now, why it is true up to some extent? See this. Most of the gases we assume as to be ideal. So if pressure is tending towards 0, this V is tending towards infinity. So P into V remained constant. So strictly speaking, if you take an ideal gas, so whatever pressure you are taking doesn't really matter. So that is only for the ideal gas that you can say that you don't define pressure doesn't really matter. Whatever way you are reacting N2 and H2 and forming NH3, delta H will be the same. But this is not the truth. Truth is this, that N2 and H2 and NH3 behave like a real gas. That is the truth. So that is why in physical chemistry, in real physical chemistry, you'll always find delta RH naught values or delta HF naught values. Strictly speaking, they are defined at 1 bar. Strictly speaking, they're always defined at 1 bar. Any doubts? If you have any doubts, you ask me, because I know there is a lot of doubt.
Sir,
These
even,
are, yeah.
even concentration is fixed to 1 mole. I mean,
Yeah, when solute is there, then concentration. We know if solute is there, then U will be defined as what? U will once again be defined as U is equals to, sorry, H will be defined as H is equals to U plus PV. But if a solute is there, what volume you are talking about and what pressure you are talking about, they have no values. Okay. Enthalpy of a solute, if you talk about, then H is nearly equal to what? U. But what happens if you have a solute? This solute at a different concentration start interacting with each other. And with this interaction, they will alter the value of U. So we also have to define in what concentration situation we are defining the internal energy and enthalpy. That is why for solute, we always choose as to be concentration of 1 mole per liter. Clear? And this all is done by this beautiful equation. G is equals to G naught plus RT ln P upon P naught. And similarly, G is equals to G naught plus RT ln C upon C naught. Here C naught is 1 mole per liter. That's called standard concentration. And this P naught is equals to 1 bar. This is how thermodynamics define these standard quantities. Now, for solute, there are other choices as well. But in your syllabus, very simple solutes are there. You'll be amazed to know that molality can also be taken because it is all depend on what standard you want to choose. So few scientists or few books or few research scientists always take molality as well. But now we don't have to go to that level, okay? For your purpose, solute 1 mole per liter. And you know, molality and molarity is not a lot of difference, okay? What do you think? Which is better quantity, molality or molarity? You'll find molality is a better quantity. Because whenever T is involved and some temperature changes are there, take molality. Because that thing is not going to be, temperature dependent. Volume may change. So it is a better measure for take molality for the solutes. But your syllabus is very simple. Here, in higher physical chemistry, sometimes we also take molality as a standard for solute. But for gas, always pressure of 1 bar. Is that clear? One last but not the least. What is the difference between delta RH and delta RH naught? They are approximately same. Because of this factor, that for gases P into V, is nearly an RT. So even if you change the pressure, see, this is not this is arbitrary pressure. Okay, they are not very much different, and that is why in calorimeter experiment you have धूम धड़ामा. ठीक है, in calorimeter what you used to do, धूम धड़ामा करते हो, इधर होता है तुम्हारे पास क्या, कार्बन C2H6 gas, you react with O2, they disappear, they form what, CO2 plus H2O. The pressure here was 25, then pressure here was say 10 atm. Afterwards the pressure is equals to say 2 atm, something like this. So you are doing all kind of different things, like C2H6 starting point was, pressure was 25 atm say, then O2 pressure was 10 atm, and then they combine, they form CO2. Suppose it is 50 atm, and suppose water is formed in the closed container. I am not measuring it, very casually I am going about. So is this the enthalpy change plus heat? Is this enthalpy change is equals to delta RH naught? Tell me first. No. But luckily that is same. Why luckily that is same? Luckily that is same because if you take from 25 atm, just do this thing, C2H6 at 1 bar plus O2 at 1 bar, react to form CO2 at 1 bar plus H2O. Now take it from 1 bar to 50 bar. T is constant. Delta H is equals to 0. Take it from 1 bar to 25 bar. Delta H is equals to 0. Take it from this to O2. 1 bar to 10 bar. Delta H is equals to 0. So what happens? This delta H, this plus this changing into this, and this delta H both are same. That is why we are enjoying this. And we never question what is the real definition of delta H. That is why. So why I told you this story? Just to tell you this story, just to impress you at this late hour? No, I don't have any such thing. Lot of other things, because delta RS is never equal to delta RS. Something like this. It is 100, then this is 10,000. It is sometimes minus 500, and this is sometimes 1,000. They are so different. Similarly, delta RG and delta RG naught, they are rarely same. But we are so lucky, delta RH is nearly equal to delta RH naught. That is the idea. The whole ITJ syllabus is based on this fact. Have you ever seen delta H varying with pressure? No. So that is why I told you this story. Keep it in mind. What is the exact definition of delta H? Okay. And in morning, I told you, I think one more thing I told you, what is the extent of reaction? What is delta H? If you have any doubt, you ask me, repeat. This concept is clear. I think, ask me, see this what I have taught here. What is delta RH naught and what is delta RH? Finally, I am writing one equation. N2 plus 3H2 changing into twice NH3. If it is at 2 atm, if it is at 5 atm, if it is at 1 atm, you maintain this pressure and somehow convert 1 mole of this and 3 mole of this into 2 mole of this. I first once again repeat, you maintain this pressure and you convert this. So whatever enthalpy change is there, heat is liberated, is called delta RH. But if N2 is there, 3H2 is there, you are making twice NH3 by this equation. If it is 1 bar, if it is 1 bar, if it is 1 bar, you maintain this pressure, and in maintaining this pressure, you are taking minus 1 mole of this, minus 3 mole of this, and converting in 2 moles of this, in this process, whatever QP is liberated is delta RH naught. This is the fact. That's what I was telling you. So how many values of delta RH is possible? Minutely, if you do the experiment, they are infinite values. If you do very minute experimentation, but they're all very, very close to what? Delta RH naught. And if the gas is ideal, then delta RH is always equals to delta RH naught. Kahani khatam. But if gas is showing significant real behavior and a very high pressure is there, they can differ considerably. That was the idea. Is that concept clear to everyone? Have I not confused you? Clear? Everyone? Is that clear?
Sir,
Yes.
for a reaction, if we started with 2 moles of N2, we
Hmm.
calculated the delta H. Now,
Hmm.
when we say delta H naught, we divide that delta H by 2 or same.
First of all, the examiner will give you the reaction. N2 plus 3H2 changing into 2NH3. Then he will write delta RH naught. That means delta RH naught belongs to this reaction. Is equals to say minus 40 kilojoule. I don't know the value per mole. Okay. Now suppose you are taking 5 mole of this. So if you're taking 5 mole of this, what is delta RH of this? So your answer will be, if 1 mole of this reacted, then you get this one. So 1 mole N2 will correspond to minus 40 kilojoule. So 5 mole N2 will correspond to 5 into minus 40 kilojoule. In other words, N of N2 into delta RH naught. Example 1. Okay, let's take example 2. Suppose I have 2 moles of A gas plus 3 moles of B gas changing into 4 moles of C gas. And delta RH naught is equals to minus 100 kilojoules. And 15 mole of A reacted. So from this, I come to know that 2 mole of A, when react, it gives 100 kilojoules. So 15 moles will give what? 100 divided by 2 multiplied by 15. Any doubt?
So when we write kilojoule per mole, what is our reference for mole with respect to whom?
With respect to either of this. With respect to, you read it like this. Finally, example 3. 2 moles of A plus 3 moles of B is changing into 4 moles of C. I have written delta RH naught is equals to 50 minus 50 kilojoule per mole. Meaning of this is, per mole means 2 mole of A or 3 mole of B or 4 mole of C. Okay. And this per mole is called per mole extent of reaction. That's what I explained you in the morning. 2A plus 3B changing into 4C. You will do it like this. Minus 2dx minus 3dx plus 4dx. Okay. So this minus 2dx, if the value of dx is equals to 1, if this dx is equals to 1, how much of A will disappear? Minus 2. How much of B will disappear? Minus 3. How much of C will form? Plus 4. That's the idea. So basically, delta RH is equals to heat liberated per unit extent of reaction. And the Unit of extent of reaction is mole. That is why it looks like kilojoule per mole. Understood?
Yes, sir.
Sir,
Yes.
does this apply also for the volume if pressure and temperature are constant?
Once again, please repeat.
Sir, does this apply same for the volume if the pressure and temperature are constant?
Yes, yes, yes. Everywhere. You want to say that if it is a delta U, 2A plus 3B changing into 4C. If you are writing delta RU, so this reaction is taking place at constant temperature and volume. Okay. Some heat is liberated, QV is liberated. Same you will apply here. And I understand why you are getting into this one. I created such there are a question I created there in the Bansal classes. So I remember that time. So for a long time, I have taken students have not taken interest in this, but here I'm finding it that you are taking interest in this one. I've created many questions and a question bank on this same concept because students always do this mistake. Okay. So same question same here as it's applied. Okay. And if you once again, if you're not clear, let me tell you. Suppose minus 2 dx has disappeared and u of a is equals to ua multiplied by ua minus 3 dx multiplied by ub. What is ua? Internal energy at under these temperature and volume conditions. And it will be 4 dx plus and uc. What is uc? At this particular instant, the value of internal energy for the C. So what is the net change in internal energy? That is equal to, you add all these quantities. Common is what? Dx minus 2 ua minus 3 ub plus 4 uc. Identify what is this quantity is. That's nothing but delta RU.